inherit traits from a parent. These are also known as sub and superclasses, which is a topic for another day. Inheritance helps with code reusability and extensibility. If all of these children classes inherit these attributes and methods from another class, we only need to write that code once and not copy it for every single class that needs it. We can write and change the code in one place for better reusability and extensibility. And well, everybody, that is an introduction to inheritance in Python. Hey everybody, so today we got to talk about both multiple and multi-level inheritance. We'll begin with multiple inheritance. That's when a child class inherits from more than one parent class. For example, a class of C can inherit the traits from both class A and B. In Python, you can have more than one parent. Multi-level inheritance we'll talk about near the end of this topic. So in this example, we're going to create two parent classes, prey, I'll write pass for now, and predator. We'll create a class of rabbit, a class of hawk, then class fish. Rabbit, hawk, and fish are going to be children classes. Prey and predator will be parents. If one of these classes, rabbit, hawk, or fish, inherit from prey, they get the ability to flee. We will define a method of flee. All we'll do in this example is print the following text. This animal is fleeing. If you're a predator, you get the method to hunt. Define hunt. We will print this animal is hunting. Rabbits, they will inherit from the prey class. They're typically not predators, except that one rabbit in Monty Python and the Holy Grail. That's the exception. Rabbit will inherit the prey class. Then it gets access to a flee method. Hawks are predators. They will inherit the predator class. Now fish, they will hunt smaller fish and flee from bigger fish. You could consider fish both prey and predators, so they will inherit both classes. We will use multiple inheritance. They will inherit everything from the prey class and the predator class. Now let's see if this does in fact work. Now we'll create a rabbit object. Rabbit equals rabbit. There are no parameters set up. We don't need to send any arguments to the constructor. Hawk equals hawk. And fish equals fish. So let's take our rabbit object, and they should have a flee method. Rabbit.flee method. This animal is fleeing, but they do not have a hunt method because they're not predators. Rabbit object has no attribute hunt. Hawks can hunt. They're predators. They inherited that method. This animal is hunting, but they can't flee. They're not prey. Hawk object has no attribute flee. Fish can do both. They inherit from the prey class and the predator class. Fish.flee. This animal is fleeing. Fish.hunt. This animal is hunting. Children classes can inherit from more than one parent, which is what we did for fish. They are both prey and predators, whereas in rabbits are just prey, hawks are just predators. If you need to inherit from more than one parent, you just add that additional class to the inheritance list. With multi-level inheritance, a parent can inherit from another parent. We will create a class of animal. And for now, I'll write pass. Prey and predator are going to inherit from the animal class, so we need to add animal to each inheritance list. Let's say if you're an animal, you get a method to eat. All animals will eat. Print this animal is eating. And you can sleep. Define sleep. Print this animal is sleeping. So think of rabbit, hawk, and fish as children classes. Prey and predator are those classes' parents, and animal is the grandparent. Prey and predator will inherit everything that the animal class has. Rabbit, hawk, and fish will inherit everything the prey and predator classes have. So now our rabbit, hawk, and fish classes should have the ability to eat and sleep, and we'll test that. Rabbit.eat. This animal is eating. Rabbit.sleep. This animal is sleeping. Let's check out fish. Fish.eat. This animal is eating. Fish.sleep. This animal is sleeping. Okay, we're going to expand upon our example a little bit. Let me zoom out. Each of our objects is going to have a name. Our rabbit will have a first name of Bugs. Hawk will be Tony, as in Tony Hawk. Our fish will be Nemo. Within our classes, we don't have any constructors set up. In which class should we assign the name attribute? Let's do so within our animal class. So we will define a constructor to assign these attributes. We will receive a name. We'll assign self.name equals name. Now with these other classes, if you're not assigning any attributes, or if you don't need any other initialization logic, you don't need a constructor. We'll implicitly use the constructor we inherit from the parent. Let's convert each of these print statements to an f-string. Replace animal with self.name. Now let's have our rabbit use the eat method. Oh, we should get rid of this. There we go. Bugs is eating. Rabbit.sleep. Bugs is sleeping. Rabbit.flee. Bugs is fleeing. Let's check out our hawk. Hawks don't have a flee method because they're predators, not prey. Let's eat. Tony is eating. Let's sleep. Tony is sleeping. Let's hunt. Tony is hunting. Let's check our fish next. Our fish can eat. Nemo is eating. Our fish can sleep. Nemo is sleeping. They can flee. Nemo is fleeing. And hunt. Nemo is hunting. Okay, everybody, that is both multiple and multi-level inheritance. With multiple inheritance, a child can inherit from more than one parent class. You just add each additional class to the inheritance list. With multi-level inheritance, a child can inherit from a parent, which inherits from another parent. Class C can inherit from B, where Class B inherits from A. Think of C as the child, B as the parent, and A as the grandparent. C will have all the attributes and methods, even available within the grandparent class of A. And well, everybody, that is both multiple and multi-level inheritance in Python. Hey everybody, so today I gotta talk about the super function in Python. Super is a function. It's used within a child class to call methods from a parent class. The child class is the subclass. The parent class is the superclass. Hence why this function is named the super function. Using the super function, it allows you to extend the functionality of the inherited methods. Here's an example. We'll create a few shape objects. We'll need to set up the classes though. We'll have class, circle. For the time being, I'll just write pass. We'll fill it in later. Class, square. And class, triangle. For each of these classes, in order to instantiate objects, we'll need a constructor. We will define our constructor, our init method. When creating circles, what sorts of attributes should a circle have? Let's say a color. What's the color of the circle? Is it filled or not? Filled will be another attribute. And a radius. Then let's assign these. Self.color equals the color that we receive. Self.filled equals filled. Self.radius equals radius. Let's do this with the square and triangle. Really, I'll just copy our constructor and paste it. Squares don't have a radius. With a square, the width and the height are the same. Let's replace radius with width. We'll also keep the color and filled attributes. Self.width equals width. Now with triangles, again, let's copy our constructor. We'll need a width and a height. Self.height equals height. So with programming, we try not to repeat ourselves if we don't have to. What do all of these classes have in common? They all share the attributes of color and filled. The ways in which they are different is that circle has a radius attribute, square has a width, triangle has a width and a height. If we have to make any changes to one of these attributes, we would have to do so manually. For example, let's replace filled with isFilled. Now I need to look throughout my code for any instance of filled and replace it with isFilled. It's a lot of work, and I might make a mistake, such as here and here. It's better to write your code once and try and reuse it. So that's where inheritance and the super function can come in handy. We're going to take the attributes of color and isFilled and place it within a parent class. These children classes will inherit those attributes. So class, what do they all have in common? They're all shapes. Class, shape. And for now, I'll write pass. Circle is going to inherit from its parent of shape. That also applies with square and triangle. We'll set up a constructor for shape. Define init. We will pass in the color and isFilled. Then we will assign these attributes. Self.color equals color. Self.isFilled equals isFilled. We don't need to manually assign these attributes within each of these constructors for the children. Instead, what we have to do is within the constructor for each of these children classes, we have to call the constructor for the parent, also known as the superclass of shape. So we will eliminate these two lines of code, use the super function, dot, call the constructor of the parent. And that is the dunder init method. But we need to pass in the color that we receive and isFilled. This will be a Boolean. Then let's do this with the square class and the triangle class. We still need radius for the circle, width for the square, width and height for the triangle. We're going to call the super function to take care of whatever attributes all these types of shapes have in common, such as color and isFilled. Now let's see if this works. Let's construct a few objects. We will create a circle named circle, call the constructor for circle. We have to pass in a color, a Boolean if it's filled or not, and a radius. So for the color of the circle, let's say red. isFilled, let's say that is true, and a radius of 5. You could even use keyword arguments for better readability, although not necessary, but for clarity, let's say color equals red, isFilled equals true, radius equals 5. Let's see if this works. I will print our circle's color. It is red. Print our color's isFilled attribute. The circle is filled. That is true. And the radius. Print circle dot radius. The radius of the circle is 5. We could even convert this to an F string. I'll add a placeholder, then add centimeters. 5 centimeters. Let's construct a square object. Square equals square. We'll need a color, isFilled, and a width. I'll just copy what we have and make a few changes. Replace radius with width. The color will be blue. isFilled will be false. The width will be 6. We don't need a height because squares have an even width and height. If we ever need the height, we can assume it's the same as the width, in this case 6. Let's check out our square. Square.color, square.isFilled, square.width. Our square is blue, it's not filled in, the width is 6 centimeters. Let's create a triangle object. Triangle equals triangle. Pass in our arguments. The color will be yellow. IsFilled will be true. The width will be 7. And the height will be 8. Let's print our triangle's color. Is it filled? Its width, and its height. Our triangle is yellow, it's filled in, the width is 7 centimeters, the height is 8 centimeters. So that's how you can use the super function to reuse the constructor of a parent class. We don't need to manually assign each of these attributes within each of the children classes. We can do that in just one place. When we refer to super, imagine that we're replacing this with the parent class name, such as shape. That might be a good way to think of it. Use the constructor of the parent class of shape, and pass these arguments in. What you could do as well is extend the functionality of a method. So within our shape class, let's create a method of describe. We will describe the attributes of this shape. We will print, use an f-string. When we want to describe our shape, let's say it is, add a placeholder, self.color. What is the color of this shape? And is it filled or not? And add a placeholder. We'll use a ternary operator. Print filled if self.isFilled is true. Else we will print not filled. Each of these types of shapes, circle, square, and triangle, will have access to a describe method. Let's attempt to use it. Take our circle, use the describe method that's inherited. It is red and filled. Square. It is blue and not filled. Triangle. It is yellow and filled. So then we also have method overriding. What if we create a similar method of describe within circle, square, and triangle? Let's do that. Define a describe method. Within our circle, let's calculate the area. What's the area of the circle? I'll use an f-string. It is a circle with an area of, then we'll calculate the area given the radius. To calculate the area of a circle, we can take pi, I'll just say 3.14 just to keep it simple, times the radius squared. Self.radius times self.radius. If I were to call the describe method, will we use the parent's version of describe or the child? So let's take our circle, use the describe method. The result? It is a circle with an area of 78.5. I should really add centimeters squared after that. Centimeters squared. This is called method overriding. If a child shares a similar method with a parent, you'll use the child's version and not the parent's. This is method overriding. If you would like to extend the functionality of a method from a parent, you can use the super function. Not only do I want to use the describe method of the child, I would also like to use the describe method of the parent. So within this function, we will use the super function. Access the describe method of the parent. What we're doing is extending the functionality of the describe method. It is a circle with an area of 78.5 centimeters squared. The circle is red and it's filled. Or you could change up the order. Let's use the parent class's describe method and extend the functionality with our own print statement. It is red and filled. It is a circle with an area of 78.5 centimeters squared. Let's finish this with the square and triangle classes. I'll copy what we have for the describe method within the circle class, but we'll make a different calculation. Describe the square. It is a square with an area of take self.width times self.width. The height and the width are going to be the same if it's a square. Then describe our triangle. It is a triangle with an area of width times height, we have a height in this case, divided by 2. We've already described our circle, let's describe our square. It is a square with an area of 36 centimeters squared. It is blue and not filled. Let's describe our triangle. It is a triangle with an area of 28.0 centimeters squared. It is yellow and filled. Alright everybody, that is the superfunction. It's used in a child class to call the methods from a parent class, also known as the superclass. It allows you to extend the functionality of the inherited methods. Within a child class, you could use it within a constructor to assign any attributes that all of its siblings have in common, such as color, or if that shape is filled. When used within any other method, you can extend the functionality of that method. Not only are we printing this message from the parent, we're tacking on another print statement before that. And well everybody, that is the superfunction in Python. What is going on everybody? So today I gotta talk about polymorphism in Python. Polymorphism is a programming concept. It's a Greek word that means to have many forms or faces. Poly means many, morph means form. In programming, an object can take one of many forms. There's 2 ways to achieve polymorphism. One is through inheritance. An object could be treated of the same type as a parent class. There's also duck typing, which we'll talk about in the next topic. In this video, we're more focused on inheritance. What we'll do in this video is create a class of shape. We'll write pass as a placeholder. We will create a class of circle, which will inherit from shape. Again, writing pass. Class square inherits from shape. Class triangle, which inherits from shape. If I was to create a circle object, circle equals circle. Our circle identifies as a circle, and since our circle class inherits from the shape class, our circle is also considered a shape. It has 2 forms. It's a circle, and it's a shape. But our circle isn't a square or a triangle. That could also apply to our square class. Our square is a square. Our square is also considered a shape, but our square is not a circle or a triangle. Those are 2 possible forms for our square. It's a square and a shape. So let's say we would like to create a list of shapes. What do they all have in common? Well, they're all shapes. A descriptive name for this list would be shapes. Equals an empty list. I will instantiate a circle object, a square object, and a triangle object. Our circle is a circle and a shape. Our square is a square and a shape. Our triangle is a triangle and a shape. Each of these objects has 2 forms, or 2 faces. Let's fill in some of these classes. Let's say that with our shape class, we will define an area method. Define area. I'm going to turn this into an abstract method. I'll just write pass. To work with abstract classes, we need to import that. From ABC, import capital ABC, as well as abstract method. Preceding the area method, I will add a decorator of abstract method. Our circle, square, and triangle classes, they're all considered shapes. They inherit from this class. We need to define an area method for each, since they're all considered a shape. Every shape has an area. With our class of circle, let's define a constructor. Define init. We will pass in 1 argument, a radius. What is the radius of the circle? Assign an attribute of radius equals the radius we receive. Let's do this with square. Define init one parameter, the length of a side, self.side equals side. Then triangle. Define init. We have two parameters, base and height. Self.base equals base, self.height equals height. All right, now let's finish defining these area methods for each class. We will return 3.14 times self.radius to the power of 2. So given a radius, that's how to calculate the area of a circle. Then with our square, define area, we will return self.side to the power of 2. Then with our triangle, define area, return self.base times self.height times 0.5. Now we have to pass in some arguments. For our circle, we need a radius. I'll pick 4. For the square, the length of a side will be 5. Then our triangle, the base will be 6, the height will be 7. We're going to write a loop to iterate through our shapes. For every shape in shapes, then we're going to print for every shape, call the area method. And that would give me these numbers. If you would like, you can format the output. I'll just use an F string. I'll add centimeter squared. Much better. What if we were to create a class that's completely unrelated to shapes? I will create a class of pizza. I will define a constructor. To construct a pizza object, we need a topping and a radius. What is the radius of the pizza? Self.topping equals topping. Self.radius equals radius. Within my list of shapes, I'll add a pizza object. But I have to pass in a topping, such as pepperoni. And what is the radius of the pizza? Let's say 15 centimeters. So our pizza class doesn't have an area method. Here's what happens when I run this. We get an attribute error. Pizza object has no attribute area. Our pizza object is considered a pizza, but it is not considered a shape. It does not inherit from the shape class at the top here. You know what? A pizza is circular. It could be considered a circle. So how about this? Let's take the pizza class. It will inherit from the circle class. And within our circle class, we're already assigning the radius to the radius attribute. So instead of doing that here within the constructor for our pizza class, let's call the super constructor. Super, which refers to the parent, use its constructor, then pass in the radius we receive. Let's see if this works now. That does. Here is the area of our pizza. Our pizza is considered a pizza. It inherits from the circle class, so it's also considered a circle. And our circle class inherits from the shape class. Our pizza has 3 forms. Our pizza is considered a pizza. It's also considered a circle, and it's also considered a shape. It would make sense for it to fit into this list of shapes, because our pizza also identifies as a shape. So that's polymorphism, everybody. It's a Greek word meaning to have many forms or faces. Poly meaning many, morph meaning form. In Python, there's 2 ways to achieve polymorphism. One through inheritance. An object could be treated of the same type as a parent. And there's also duck typing, which we'll discuss more in the next topic. Stay tuned for that. And well, everybody, that's polymorphism in Python. Hey everybody, so today I gotta talk about duck typing in Python. Duck typing is another way to achieve polymorphism besides using inheritance. Objects can be treated as if they're a different type, as long as they meet the minimum necessary attributes and methods required of them. It follows this adage: if it looks like a duck and quacks like a duck, it must be a duck. As long as an object resembles another, it could also be treated of that type. So in this example, let's create a class of animal. We will have a class attribute of alive. If you're an animal, you will have an attribute of alive. You're a living creature. Let's create a class of dog. The dog class will inherit from the animal class. They will inherit the alive attribute. Let's also define a speak method. If you're a dog, you gain the ability to speak. We will print woof. Then we'll create a cat class. Class cat inherits from animal. For the speak method, we will print meow. Let's create a list of animals. What do these two classes have in common? They both could be considered animals. Let's create a list of animals. We will construct a dog object and a cat object. If I was to write a for loop for every animal in my list of animals, have each animal use its speak method, which will result in the dog going woof, the cat going meow. They're both speaking. What if we add a class that has nothing to do with animals? Like class car. Cars will have a horn method. That's how they speak. When you honk the horn, you will print honk. Within my list of animals, let's create a car object. It really doesn't belong in here, but let's see what happens. We have an attribute error. Car object has no attribute speak. Our car object doesn't have the minimum necessary attributes and methods. When iterating through this list of animals, we're calling each animal speak method, which our car object doesn't have, but it does have a horn method. So what if we rename our horn method as speak? Maybe it's an AI car or something. Well, this would work. The dog goes woof, the cat goes meow, the car goes honk. So our car object, it quacks like a duck. We could consider it a duck. It has the minimum necessary methods to be considered an animal. Animals inherit this alive attribute. Let's utilize that. After the animal speaks, let's print their alive attribute. Print my animal's alive attribute. My car object doesn't have that attribute. We get an attribute error. Car object has no attribute alive. But if I was to add that attribute, alive equals false, we have true for the dog, it's living, true for the cat, it's living, but false for the car, it's not living, it's not a living creature. My car meets the minimum necessary requirements to be considered an animal. If I were to set this to be alive, well, then it would be a living car, kind of like the movie Cars. So with Python, duck typing is another way to achieve polymorphism besides using inheritance. As long as an object has the minimum necessary attributes and methods, you could treat it as a different type of object. If it looks like a duck and quacks like a duck, it must be a duck. And well, everybody, that is duck typing in Python. Hey, what's going on, everybody? Today I'm going to talk about static methods in Python. A static method is a method that belongs to a class rather than any object from that class, any instance. Instance methods, we're already familiar with them. They are methods that belong to individual objects created from that class. They're best for operations on instances of that class, any objects. Whereas static methods, they're best for utility functions within a class that do not need access to class data. I'll demonstrate the differences between an instance method and a static method. We'll begin by creating a class of employee. We'll need a constructor. Let's define that. To create an employee object, we'll need a name and a job position. We will assign self.name equals name, self.position equals position. We will create an instance method of getInfo. We will return employee info. We will return an f-string where we will display self.name equals self.position. GetInfo is an instance method. Each object that we create from this class will have their own getInfo method to return the information on that object, the object's name and the object's position. Now we'll create a static method. To create a static method, we need a decorator of static method. Static methods are best for general utility functions within a class. We'll define a method to check to see if a job, a position, is valid, which we will name isValidPosition. So static methods, they don't have self as the first argument. We're not working with any objects created from this class. To check to see if a position is valid, we will pass in a job position, which I will name as position. I will create a list of valid positions. Let's assume that our company is the Krusty Krab. What are some valid positions? A manager is a valid position, a cashier, a cook, then let's say a janitor. Then we will return, we'll use a membership operator. Check if position that we receive is in our list of valid positions. What we have done is that we have created a static method. We don't need to rely on any objects to use this method. For example, to use a static method, we will use the name of the class, rather than any object that we create from this class, such as this. We don't need to do that. We type the class name, followed by the static method, isValidPosition. Then I did set this up to accept one argument. Let's check to see if a cook is a valid position. Then I do need to print this. What is the output? A cook is a valid position. What about a rocket scientist? That would probably be Sandy's job. That is false. A rocket scientist is not a valid position at the Krusty Krab. This is a static method. It belongs to the class, not any object created from that class. Now let's create a few employee objects. Let's say employee1 equals a new employee. We have to pass in a name and a job. Eugene will be the first name. That's Mr. Krabs. He will be a manager. Employee2 equals employee. Squidward will be a cashier. Employee3 equals employee. Employee3 will be SpongeBob. SpongeBob will be a cook. To call an instance method, we have to access one of the instances of the class in order to use it. If I want to check the info on employee1, I will access that object, that instance, use the getInfo method, then I need to print it. Take employee1, get the info. Eugene is the manager. Let's do this with employee2 and employee3. Eugene, Mr. Krabs, is the manager. Squidward is the cashier. SpongeBob is the cook. For an instance method, you access an object, then call the instance method. With the static method, you only need to access that class. You don't even need to create any objects from that class. It's a general utility method. Alright everybody, those are static methods. They're a method that belongs to a class, rather than any objects created from that class. They're usually used for general utility functions that do not need access to class data. And well, everybody, those are static methods in Python. Hey, what's going on, people? So today I gotta talk about class methods in Python. A class method allows operations related to the class itself. They take CLS as the first parameter, whereas instance methods will take self. Self refers to any object created from that class. CLS, meaning class, refers to the class, not any objects. Here's an example. We will create a class of student. We'll need a constructor to construct some student objects. All students will have a name and a GPA. Self.name equals name. Self.gpa equals GPA. We will also create a class variable for this demonstration of count. We will count how many students we create. Whenever we construct a student object, we will access the class of student, take our count variable, increment it by 1. Whenever we create a student object, increase count by 1. I will create an instance method of getInfo. Instance methods have self as the first parameter. We're referring to the object we're currently working with. I will return an f-string where we will display the student's name and their GPA. Self.name, self.gpa. I'll add a comment that this is an instance method. Now, to create a class method, to work with class data, we will declare a class method with a class method decorator. Class method. What we're going to do is define a method to get the count, the class variable of count. This method will be called getCount. Rather than self as the first parameter, we'll be working with a class, CLS, meaning class. I will return an f-string, total number of students, add a placeholder, CLS count. Let's test this. To call a class method, you take the name of the class, followed by the class method, getCount. And then we do need to print this. What is the count of my current students? Total number of students is 0. Let's create a few student objects. We will create student1 equals, call the student constructor. We have to pass in a name and a GPA. Let's say that the name is SpongeBob. SpongeBob has a GPA of 3.2. We'll create 2 more students. Student 2, student 3. Student 2 will be Patrick. Patrick has a 2.0. Then Sandy. Sandy's smart. In fact, she's a genius. She has a perfect 4.0. Now let's count the number of students. Total number of students is 3. When we call this class method, we can access or modify class data, this class variable of count. Rather than using self, we use CLS for the class. Let's create one more class method. This time I'll calculate the total GPA of all my students. We'll need a class variable to hold that data. Let's say total GPA equals 0. Whenever we construct a student object, we will access our class of student, get the total GPA, then add plus equals this student's GPA that we have just created. Basically speaking, the total GPA, this variable, is going to accumulate all of the GPA of every student and store it as a sum. To find the average, we're going to divide it by the count, the number of students. We'll do that within a class method. To create a class method again, we need to use the class method decorator. I will define a method of getAverage GPA. The first parameter is CLS for class. I will check if CLS count, the count variable of my class, is equal to 0. That means if we have no students. If that's the case, if there's no students, we're going to return 0. Because otherwise we're going to divide by 0, and we'll get an error. Else, we're going to return an F string. Follow this formula. We're going to take the total GPA of my class, class.totalGPA, divided by class.count, the number of students we have. That's how to calculate the average GPA. After getting the count of the number of students, to access a class method, we take the name of the class, student, call the class method, getAverageGPA. Then I will print it. Total number of students is 3. The average GPA is 3.06 repeating. After calculating the average, I'm going to add a format specifier of 0.2f, just around to 2 decimal places. And I'll add average GPA :space, then we'll calculate the average. Alright everybody, those are class methods. Instance methods are best for operations on instances of the class, any objects. Static methods are best for general utility functions, which do not need access to class data. Class methods are best used when we're working with class-level data or we require access to the class itself, such as when we're working with class variables. Rather than using self as the first parameter, we're going to use CLS, meaning class. And well everybody, those are class methods in Python. Yo, what's going on people? So today I'm going to explain magic methods in Python. Magic methods are also known as dunder methods, meaning double underscore. You typically find these within classes. We're already familiar with one of them, our dunder init method. We have double underscores on the left and double underscores on the right. But there are others. I'll cover a few of the more beginner-friendly ones. So what these methods do is that they're automatically called by using some of Python's built-in operations, such as printing an object, seeing if two objects are equal, greater than or less than. When we use many of Python's built-in operations with objects, we can define and customize the behavior of those objects. So in this demonstration, I'm going to create a class of book. We will construct some book objects. We will define a magic method, a dunder method, of init, to initialize these objects. For a book, we need a title, an author, and the number of pages. We'll say num pages. Self.title equals title. Self.author equals author. Self.number of pages equals number of pages. When we call the class of book, we are automatically calling dunder init. So let's create a book object. Book1 equals book. We need a title, an author, and number of pages. So since we're dealing with this topic of magic methods, I'll pick some fantasy-related books. For my first book, I'll pick The Hobbit. That's the title. The author is J.R.R. Tolkien. The number of pages is 310. So for my next book, book 2, I will pick Harry Potter and the Philosopher's Stone. The author is J.K. Rowling. The number of pages is 223. Then we have book 3. For my third book, I will pick The Lion, The Witch, and The Wardrobe. The author is C.S. Lewis. The number of pages is 172. Okay, here are my 3 book objects. When we call the class of book and pass in arguments, we will call the dunder init method. It's a magic method. It's automatically called behind the scenes. Within this magic method, we can define and customize the behavior of objects. And in this example, we're just assigning the attributes of title, author, and number of pages. That is one built-in operation of Python. What would happen if I was to print book 1 directly to the console? Here's what happens. Well, we're given a memory address. Here's book 2 and book 3. Well, we can customize this behavior. We will use the dunder string method. Double underscore, str meaning string, double underscore again. We have one parameter of self. Instead of returning a memory address, we can customize this behavior. Let's instead return an f string. I'll add two placeholders. We will display self.title, the title of the book, by self.author. And I'll place the title within single quotes. Now let's print book 1. We have The Hobbit by J.R.R. Tolkien. Let's print book 2. Harry Potter and the Philosopher's Stone by J.K. Rowling. And book 3. The Lion, the Witch, and the Wardrobe by C.S. Lewis. So that is dunder string. We can return a string representation of the object when we print it directly to the console. Here's another dunder method. We can check to see if two objects are equal. I will print is book 1 equal to book 2. That gives me false. If they were to have the same title, the same author, and the same number of pages, then Python would say they're not equal still. So let's customize this behavior. We will define a method of dunder equals, which is just eq. For parameters, we have self, the first book we're examining, in this case book 1, and other. Other means the other book. We're examining two objects for equality. To do that, we'll see if the title of two books and the author is the same. We'll disregard the number of pages. You can have two different versions of the same book. They might have different font sizes, or the dimensions of the physical pages might be different. So we will return a Boolean value. We will examine if self, that's the first book, is the title attribute equal to our other book's title, and is the author of the first book, self.author, equal to our other book's author. If I were to run this, we get false. Book 1 does not equal book 2, but if they have the same title, I'm going to replace these, and the same author, then they would be equal. And we'll disregard the number of pages. Let's say that with this version of The Hobbit, they're using a smaller font size, so there's less pages. We're using dunder equals to compare if two objects are equal. What if I was to print book 2 is less than book 3? Like, what does that even mean? And I'm just going to get rid of these two lines. Type error. Less than is not supported between instances of book and book. So we can't use less than on two objects. But we can customize that behavior by using dunder less than, which is just LT. We're examining one book and the other book. Self and other. Let's compare the number of pages. We'll compare if the pages of book 2 is less than book 3. We will return a Boolean value. Is self.number of pages less than other.number of pages. So now, this should not give us an error. Book 2 does not have less pages than book 3. Another would be greater than. I'll just copy what we have. Dunder GT for greater than. For our first book of self, is it greater than the number of pages of the other book? Well, that's true. The number of pages of book 2 is greater than book 3. Let's use dunder add to add the pages of two books together. What would happen if I were to add two books together? Book 2 plus book 3. Well, we get a type error. Unsupported operand for book and book. Well, to customize the behavior of addition, we will define dunder add. We have self and other for the other object. Let's add the pages together of 2 books. Maybe we need a summer reading list and we would like to see what the total number of pages is. I will return self.number of pages attribute plus our other book's number of pages. That would give me 395. That's 223 plus 172. Heck, I'll even put this within an F string. 'Cause why not? Then I will add the word pages. 395 pages. Within an object, we can search for a keyword within one of the attributes. So let's find the word lion within book 3. To do that, I would write a statement like this. Lion in book 3. Type error. Argument of type book is not iterable. We will define dunder contains. Besides self, we will pass in a keyword that we're searching for. I will return, then we'll use the in membership operator, is our keyword in self.title. I'm looking for the word lion. That's going to return true if lion is in the title of this book. Or is our keyword in self.author. Maybe we're searching for an author. Let's try that again. That returns true. Lion is in book 3. However, lion is not within book 1. That's false. Is rolling in book 2. That's the author. That is true. Is rolling in book 3. That is false. That is dunder contains. We are searching for a keyword in an object. Now we could search for a key given an object. For book 1, we'll use the index operator and look up an attribute. Let's get the title of book 1. The default behavior is that we get a type error. Book object is not subscriptable. So to customize this behavior, we will use dunder get item. Besides self, we have one parameter of key. We're accessing book attributes by indexing. With this object, return the value at this key. What's that attribute? We will check if our key that we receive is equal to title, which it is in this case. We will return self.title. What's the title of the book? So that would give me The Hobbit. Here's book 2 and book 3. What if the key is author? None. We didn't set that up yet. If key is equal to author, then return self.author. The author of book 3 is C.S. Lewis. 2 is J.K. Rowling. Book 1 is J.R.R. Tolkien. What about number of pages? Num pages. Well, we're not set up for that yet. I'm going to turn this into an else if statement. Else if key is equal to num pages, then we will return self.num pages. The number of pages in book 1 is 310. Book 2 is 223. Book 3 is 172. What if there is no key? Otherwise, if there is no matching key, I'll add an else statement. Let's return an F string key placeholder. Our key that we pass in as an argument was not found. What do books not have? Well, they don't have audio, I guess, unless it's an audio book. Is there a key of audio in book 3? There is not. Key audio was not found. And I'll place that within single quotes. Much better. Alright everybody, so those are magic methods, also known as dunder methods, meaning double underscore. They are automatically called by many of Python's built-in operations. They allow developers to define or customize